Okay, so we have these properties of radicals. We can split them up or we can put them together. And in the concept here, they're splitting them up. A big radical can be split into two radicals. It doesn't have to stay for the whole thing. It can be pieces. And then in the example, they do the opposite. They start with the pieces and they go to the big thing because it helps them. So I think you might look at the work we're going to do here and you're going to say, I'm not sure if this really fits, but maybe what they were trying to get you to think of here for this one is to say, oh, I can put these threes together, under a radical, and you say, hey, wait a minute, this is a 3 and this is a 4. I can't put them together. Okay, fine. So here's what we do. We say, this is the same thing as 3 to the 1/3, okay? Because there's a 1 on there, and the 3 is on the bottom. It's a terrible looking exponent. Let me try that again. 1/3. And then I'm multiplying by 3 to the 1/4. Okay, that's the 1 here. And the whole thing is to the 12th power. Well, this is the one time I'm allowed to multiply exponents, when I'm outside of parenthesis like this. So I'm going to say, same thing as 3 to the 4th power. Well, I better say 12/3 first. And 3 to the 12/4, because I multiply my exponents. And this gives me, what does this give me? 3 to the 4th times 3 to the 3rd. And now I have a common base, and I can add exponents. So I get 3 to the 7th. I don't multiply now. I don't multiply those exponents now. Now I add. The only time I'm allowed to multiply exponents is when I'm outside the parenthesis there. Here, I've got to add these guys. Okay, so I get 3 to the 7th, and that is good. And if I was curious about what 3 to the 7th was, I'd pick up my calculator, because I don't know. 3 to the 7th power is 2,187. But we'll be content with 3 to the 7. We're just supposed to simplify this. Okay, now here we have a situation where we actually can use the formula. If you look up here at the formula, which is so much smaller, the formula says that if you have two things that are split up, we can put them back together inside one big one. And that's what we're going to do down here. We're going to say, notice that it's the 7th root for both of them. I can't draw here. 7th root for both of them. So let me rewrite this as 13 to the 3rd power. And it's the 7th root of that. And I'm going to say 13 to the 5th power. And, oh yeah, it's the 7th root. So, and then I can put these guys together because I have 13 to the 3rd over 13 to the 5th. And it's one big radical. It's the 7th root. And then I can subtract exponents, right? I don't know. I was going to say 3 minus 5. I guess I could just cancel them. I'd get 13 to the minus 2, and then I'd just put it back on the bottom. So let me say the 7th root of 1 over 13 to the 2. Okay? You can see, 3 minus 5, yes, okay, negative 2. So I could have had, 13 to the negative 2 over 1, but I don't want to have a negative exponent, so I think I'll be content with this. This is a good stopping point right here. 13 times 13 is, 169, I think. For some reason, I can't remember at the moment. Yes, that's it. And so we'd have 1 over 169. And I think I can say with a fair degree of certainty that that's not going to be a nice, easy, it's not a nice whole number. So we'll just leave it there.